Hey guys, welcome to Unit 2.4, Factoring with Special Cases. Before we get into our unit, let's review really quick on how do I multiply and factor. So, multiplying to binomial, I will do the box method. Those of you that did this with Miss Shiny in Algebra 1, g minus 5. Remember, I keep the sign with me, and g plus 5. So I'll fill in each boxes. G times g, g squared minus 5g. Go this way, 5g, and this is a negative 25. Negative 5 plus times a positive 5 is a negative 25. So I will go ahead and always combine like terms. In this case, I will get g squared minus 5g plus 5g minus 25. These are my like terms. When I combine those, minus 5g plus 5g is actually 0. So we don't write 0 in math. And then this becomes my final answer. Take a minute, pause the video, and try the second one on your own. Great, now you got a chance to try that. Did you get 4x squared minus 9? Great job if you did. If not, just look at what mistake you made. It's okay. Factoring, remember, what's my A, what's my B, and what's my C? My A is 1, there's no B term, so it's a 0. My C is negative 16. So negative 16 goes on top, 0 goes on the bottom. Remember, it's A times C at the top and B at the bottom. Remember a trick, whenever you have 0 at the bottom, it's going to be the same number. So two numbers that I multiplied to get negative 24, and when I add it to get a 0. And that is going to be positive 4 and negative 4. And because my A is 1, all I need to do is write B plus 4 and B minus 4. You will see in example number 2, my B is not equal, my A is not equal to 1, sorry, and then there's something else special. So pause the video and try this one on your own really quick. Great. You got a chance to try it. Now this one was a little tricky. Same goes, my A, my B, and my C. A times C is 36, negative 36, and 0. Now it's negative 6 and positive 6. I'm pretty sure we all know how to get this. Now be very careful. A is equal to 4. My A is equal to 4, which means now I need to replace my B term. There was no B term, so I'm going to be inserting the negative 6y and the positive 6y here. And just like what we did before in previous lessons is to factor this out. You should have gotten 2y plus 3, 2y minus 3. These are special quadratics. They're known as something called the difference of squares. So hold on, what just happened? Here we go, technical difficulties there. As we were saying, these are called your difference of square. Whenever I have the A term and the C term and I can write them to the second power with no B term, it's always going to be whatever those two numbers are, and one's going to be addition in the middle and one's going to be subtraction. Now here's how this works. Very easy. I can factor and solve this quadratic here in less than 15 seconds. So I know v squared is already there, and I know if I take the square root of 81, that's going to be 9 squared. Notice that every term is raised to the second power, so all that I have to do right now is I know it's going to be v plus 9 and v minus 9 in parentheses. And that's my final answer. That's a 9. I can go ahead and do A equals, B equals, C equals, but it takes so much time. This way is unbelievably easy. Now let's look at example 2. Take the square root of both sides. This becomes 6 squared k squared minus 11 squared. All of this is raised to the second power, so I know it's going to be 6k minus 11 and 6k plus 11. It doesn't matter which one I write first, but I solve both of these in less than a minute. Now, again, really quick review. Whenever you have something that's, say, g minus 5 squared, we know that that's the same thing as g minus 5 and g minus 5. So, I want to multiply these, make my box, g minus 5 g minus 5. I'm going to fill these in with g squared minus 5g minus 5g, and this is a positive 25. And here again I'm going to combine my like terms, and I will get g squared minus 10g plus 25. And that is that g minus 5 square expand. So you know what to do. Pause the video, try number 2. Now that you're back and you got a chance to try it, did you get 4x squared plus 12x plus 9? Hope you did. If not, you know what to do again. Review what you just did. Now moving on to factor. Again, it goes with a equals 1, b equals negative 8, and c equals positive 16. Make my x. 16 goes on top, negative 8 go on the bottom. Now, two numbers, when I multiply it, I get a positive 16, but when I add it, I get a negative 8. Negative 4 and negative 4. Again, my a is 1, check, and I know all I'm going to write here is b minus 4. Let me just make that minus better. B minus 4 and b minus 4. But because we're such scholars, we know b minus 4 and b minus 4 is the same thing as writing b minus 4 squared. Now try number 2. Be very careful because again, b is greater than 1. So now you got a chance. Now look here. Really quick. A is 4, B is 12, C is 9. I got up to here perfect. Now because A is equal to 4, I know I need to replace my middle term. In this case, it's going to be 12W right here with what I just found. Once you do this, this is just like the other unit that we did by solve this by factoring. Now, these are what's known as perfect squares. So perfect square is when I can square the first number and the second number, something to the second power. And if I multiply these two numbers and then times it by 2, I'm going to get the middle number. Notice whatever is next to my middle number, in this case addition, tells me what goes in the parentheses. Here it's subtraction, so I know I have to put a subtraction here. Now let's see how does this work. So the first thing I want to do is square this. This is already x squared plus 20x plus square root of that is 10 squared. So I check. This is 1, that invisible 1 that's there, and this is 10. So I say 1 times 10 is 10, and if I times that number by 2, I get 20, which is my middle number. I know that's exactly what I want to do, so I know it's going to be x, and it's going to be a 10, and it's going to be something square. It's always going to be these two numbers at the top. Now, what sign goes here depends on what's in front of the middle number. In this case, it's a plus. That's my final answer. Now let's look at this one here. Again, see, now I have a 25. I have to take the square root of this. So this becomes 5 squared x squared minus 60x, and then the square root of 36 is 6 squared. So I know this is a 5 and this is a 6. 6 times 5 is 30, and if I times this by 2, I get 60, which is what I wanted. So I know this is going to be 5x with a 6 and something square. What sign goes here? Look in front of the 60, it's a minus, so I know I have to put a minus there. And that becomes my final answer. Now moving along, let's see what it means to factor completely. If I look at this, I can see that I can take a 2 out. If I take the 2 out, what does this become? 2. This becomes 18p squared. No, 16, sorry. This becomes 16p squared plus 8p plus 1. Now that I see this as a quadratic, let's see, can I take the square root of this and take the square root of that? I'm going to keep my 2 outside and rewrite this as 4 squared p squared plus 8p plus 1. 1 squared is the same thing as 1, so it doesn't matter. This is 4 and this is 1. Let's check it. 4 times 1 is 4. And if I multiply this by 2, I get 8, which is what I want. Perfect. So I'm going to keep this 2 outside. And I know because this works, I can use my perfect square trinomials. So I'm going to go back here, and I know this is going to be 4p, and it's going to be 1 outside. Again, let me just rewrite this. Looks like 1 square. There you go. So what sign goes here? Whatever's in front of my b term, in this case it's a positive, and don't forget I have to put the square. That is what it means to factor completely. Now look at example 6. Notice I see an r in common, and I also see a 3. Good. So when I take that out, this becomes 4r squared minus 25. Perfect. And if we know, these are all perfect square roots. So this is actually 3r, 2 squared, r squared minus 5 squared. And this is from the first one, the difference is square that we talked about. So I'm going to keep the 3r, and I know difference is square, meaning one is going to be minus and one's going to be addition. Here we go. Perfect. So just moving along really quickly, here I can check this. P squared minus 30p plus 15 squared. So we're going to check this out. This is 1, this is 15. 1 times 15 is 15, times 2 is 30. Bam! I know that's going to be a perfect square. So we're going to go ahead and write this up. So I know it's going to be p and a 15 something square. Again, what goes in the middle? Whatever's in front of that 30. So in this case it's minus, bam, p minus 15 square. Solve and sketch this. So before I solve this, I need to get this in ax squared minus 28 on both sides. I'm just going to write it plus 49 equals 0. Now it says solve. So before I even solve, I have to factor it. I know this is the same thing as 2 squared x squared minus 28x plus 7 squared. Check my numbers. This is a 2, this is a 7. 2 times 7 is 14, and then I times it by 2, I get a 28. Perfect. So I know it's going to be a 2x and a 7 something square. Now what do I put here? What's in front of the 28? A minus sign. Bam. Now they asked me to solve, so really important. When it says solve, it means that I'm going to set this equal to 0. So when I set this equal to 0, and I'm going to come on this side here to solve this, is going to be 2x minus 7 equals to 0. 2x is equal to 7. X is equal to 7 over 2, which is 3.5. Now the reason why I say sketch this is if you graph this, all this means is 3.5, let's say it's right here, it means that the graph is only going to touch the x-axis one time. Remember, this is your x-axis and this is your y. All it means is that your graph is going to touch the x-axis one time. Okay, so solve it. This is my solution and this is my graph. Perfect. Now last example, find the zeros and sketch it. So I know that finding the zeros is the same way of saying solve it. So x squared minus 64 equals to 0. X squared is equal to, oh, I'm not equal to, let's, x squared minus 8 squared is equal to 0. I know this is actually what? Difference of square. Excellent. How do you know it's a difference of square, Miss Amru? Because there's no b term. So I know it's going to be x minus 8 and x plus 8 equals to 0. So when are these two things equal to 0? It's going to set x minus 8 equals to 0, x plus 8 equals to 0. I know x is going to be positive, x is going to be a negative 8. When I sketch it on a graph, let's just say this is negative 8 and this is positive 8, it means that the graph is going to pass through twice, at negative 8 and positive 8. So what you're going to do is work on portfolio 2.4. What you need to know is when is it a difference of square or when is it a perfect square. So perfect here, OCT, and difference here. Okay? Keep this up. Refer to these formulas. Great job, guys.